Hello everyone. Today's video is about another experiment in my series, a project where I'm trying to use the RPi-4B with the CM-550. In this video, I'm trying to show you how I could share the LiPo battery between the RPi-4B and the CM-550. So I use two voltage converter. We'll show the detail later. I had to modify the battery cable a little bit. And then I also have some video showing some runtime performances. First, very important disclaimer. You modify this part at your own risk. The reason is the battery comes with a 6-month warranty. So when I work on my LiPo battery here, it's way out. It's almost a year old. So the warranty is gone anyway. So be careful on how you want to do this. You may have to, if you have a brand new kit, I think you should wait. Because I don't think ROBOTIS will like how we modify their equipment. So first, although I can modify the cable at this point, I prefer to modify the extension cable itself here at this spot. And also right now, for some reason, this LiPo battery extension cable is not sold separately from the battery pack itself. Maybe later in the future, ROBOTIS will change their mind and sell us this extension cable in case you need it. But it's just a cable, so in case you cut it, you mess it up, you can always kind of splice some new wire in and we'll be okay. First converter I use is CPT one. As you can see, it used in the automotive industry. It hermetically sealed, watertight and all that, which we don't really need for our needs right now. But the nice thing about it is it has an output. It already have a USB-C already. So this will go into the RPi-4B nicely. And the other end is just bare wire that we need somehow splice into the ROBOTIS LiPo battery extend cable. Now, there are similar products available in the market for different companies. Some go to 4.2 amp max 2. So I just pick up on that day, just trying to find the cheapest one I can find and see what I can do with them. So I got this one. So the LiPo battery extension cable from ROBOTIS here. So you see I carefully mark which one is a positive cable. The red one that connected to this red cable so that I don't get mixed up. So you can see in my first attempt at doing it, you can see I didn't do too good job at removing the insulation there. I got some frail strands here, so I had to put in a little bit of soldering just to keep it from falling apart before I can get to it. And then I just splice the input of the CPT module into the spot here. So then just tape them for securely. So this end therefore will pull to the ROBOTIS LiPo battery itself. The end go to the CM-550 as usual, and then the USB-C will of course go to the RPi-4B to power it. This is what it looks like when put all together on a modified Pentium COMMANDO. And you see, my cable management is still to be desired. Sorry about that. But the RPi-4, so the converter module, you can see it sits on top of the RPi-4B here. And the RPi-4B is different now from the previous video that I made using this project. This time I use an 8GB RAM version, and also I put a 64-bit Raspbian on it. Raspbian is right now in beta stage, but it got enough part of it working that I can do this project, so that's why I'm going to try it out. So as usual, it sits on top CM-550. The RPi-4B will process images, video coming from USB cam, and then once it decides what to do, it will send command via the LN101 to the CM-550, which is running as a simple task program so that it can maneuver the robot as the RPi-4B wants it to do. Okay. The second voltage converter used is a DAOKI. So this one here you can see is a little bit bigger and kind of more bare bone. It had 2 input type, a barrel if you want to use. I use a terminal block. You can put in 12 volt. And because I use a terminal block, so the actual wire I am using a single core wire now, so it's a little bit more sturdy when you clamp it down on the terminal block on this end. The output and also have 1 terminal block, which I usually just to monitor to see which volt I get out of it. It's about 5.2 volt when you put the ROBOTIS LiPo battery into the input. It's a USB-A. So I had to buy an extra short little cable that will convert USB-A to USB-C so that I can use an RPi. So this option is a bit more expensive and you have to buy more things. But I think it provides a bit higher amperage. I forgot. I think it's rated to go up to 5 amp, this board. Again, similar product available on the market. Some of them just have a black one, but you can see the circuitry is exactly the same. Some even come as a version where you can vary the output voltage and you have the little embedded voltmeter on it. Just depend on your budget, alright? Okay. On this one here, because it didn't have the nice case around it like the CPT one, so I just put a shrink tubing on it. Help it save it from a little dust, but it have enough air still can flow and cool itself. You can see that I cut out a piece on the shrink tubing when everything is done, so I can access into the terminal block, you know, to put in or remove the cable, the input cable here. So put all together on the Pentium platform again, it looks like this. Not much that different from the other one. So what is the programming tool I use on the RPi-4B? The same thing as in the other video. Code blocks. I use a CC++ version only. This time on the 64-bit RPi-4B, Thorny doesn't quite work properly yet, so I couldn't use Thorny, and I using Python. So the code. This code I explained in the previous video too. It came from my volume book of the engineering book here. The important thing here, this time, OpenCV x86K, I had to rebuild it for the 64-bit version. And it definitely, as you can see later, there's lots of good benefit on the speed, processing speed. Okay, so same as before, we use a Wi-Fi communication between the PC and RPi-4B. When I develop and doing demos of the robot. So the VNC server is on RPi-4B and I use the VNC viewer on the PC to have a look and access and all of that. So in this first demonstration video 1 here, I'm using the CPD converter. Okay. So first I show you basically the physical situation a little bit, and then there's a second video of this part, the second part of it, showing how it's tracking this blue blob. Here we go. So that's a physical lookup. Oh, I'm sorry. Let's try it again. So what the screen look like. So I just tell to extract the blue blob and it look good, okay. It's the hue value there. And then it start tracking now. It's an XY. So this is the open target. So that's the cleanup that the image process. And then physically down here, see how it looks like. Yeah, start moving the blue blob. You can see it too well. Hang on. So I just want to show you how fast it is OpenCV now. How it processes the image, the video frame pretty quick now. Yeah, here we go. So if you move the blue blob closer to the robot, it move away. If you move further away, it come forward. And then you can see move it to its left, track left. move right, attract right. And then you just leave it alone. It should stop. Here we go. Alright. So this is the next one, the DAOKI converter one. It follows similar designs. So first the physical layout, and I show you some of the program interface, how it's running, and then we'll see a demo. So the little menu there. So first vision, that's how it looks like at that time. Okay, now I already got the ROI in there. I'm going to extract the property of the ROI. Here we go, it did it. And then I put it actually in tracking mode. So real soon, here we go. It started giving X, Y coordinate of the screen. Here's what it got when a huge buffer is contracted. So this is the one that gives us X and Y coordinates. Here we go. Let's swing over here. So I move to the left, move forward, so it backed away from the target. Move the target away, come back forward again. Move it left, attract left, attract right. Okay. And we'll swing back to the screen, and just to show you how fast the OpenCV processing steps can be done now. You see that? Between here and here, that's pretty decent here. So 64-bit RPi-4B is quite decent. So far for this project, on a fresh ROBOTIS battery, I spent about 10-15 minutes doing all these demo, and the CM-550 and the RPi-4B, both of them do not complain anything about low voltage on that LiPo battery from ROBOTIS. So obviously you can see that I use it for demonstration or runtime, but if you actually developing software for it, you have to use the regular AC power supply, because it's going to run out of battery all the time. So that's it. Until next time.